Good afternoon. Transportation Systems Management. Module 4, Local Area Traffic Management. So, in this session, we will be discussing the various traffic management measures adopted for local area. So, it includes promotion of non-motorized modes. So, how can we adopt measures which can restrict the traffic flow, and thereby we can manage a particular local area? So for that, the various non-motorized modes which are adopted are the topics which we are dealing in this session. So in the previous sessions also we have discussed various non-motorized modes in order to reduce the traffic flow. Some of the non-motorized modes are the land use and city planning controls, then transportation traffic restraint measures like restriction on parking, official measures such as road pricing and entry charges. All these we have already discussed in the previous sessions. Promotion of public transport, then pedestrianisation in congested cities, staggering of working hours, etc. So these traffic restraint measures are becoming increasingly popular in many cities, and the basic idea here is to impose certain measures calculated in order to restrain the use of a road by the traffic. The main techniques which we have discussed before, in addition, so some of the main techniques we have already discussed, and in addition to that, today we will be discussing more about pedestrianisation and bicycle transportation and also the management. Okay, so in that case we will first discuss what is pedestrianisation. So if you are completely banning motor vehicles from certain areas and declaring that particular area as pedestrian precincts, then that is the definition of the term pedestrianisation. So it is actually a great effort. It will have a great it's actually meant to increase the safety of the pedestrians. Also this is a very salutary effect. This will have a very salutary effect on the traffic situation, and this is also a particular non-motorized mode for managing the local area traffic. So this pedestrianisation, or completely banning a particular street of the motor vehicles and also declaring that as a pedestrian precinct. Okay, so that will have great effects on the pedestrians. It will, suppose we know that especially in Trivandrum, let us take the case of East Fort. Okay, so there are certain streets inside the within this particular zone where the regulations are there, and you can't actually travel through that area by say four-wheelers or or bus or such modes are restricted on certain lanes inside the East Fort. The certain areas are there, so we know that we have to park at somewhere near the central bus stand and from there you have to either walk or you have to just use a motorcycle or something, and then only you can reach these areas where the four-wheelers are restrained. So such areas are mainly shopping zones. Okay, so there will be a lot of shops, and people, there are a lot of people on the roads near leading to these shopping areas. So we know that such areas are or such areas can be termed as can be seen as an example of this pedestrianization. Okay, I hope the idea is clear. So it gives the pedestrians the freedom to move about and shop leisurely. So the aim is to reduce the vehicles, or to completely ban the vehicles in that area and allow the people to freely move about and do their shopping. Okay, so it frees the area from noise, fumes and smell, contrary to the belief that it may affect adversely the shopping turnover. It has led to an increase in business. So that is a proven fact. By and large, the motorists, the pedestrians and the commercial interests and their interests, people who are interested in buying people's things, they all have agreed that this is having a beneficial result on that particular area, that selected location. Okay, so another term which we will be dealing here is promotion of bicycle traffic. So that is also another method of non-motorized mode. So bicycles, as we know, they are an important mode of personal transport, particularly for the unprivileged sections of the society, especially in India. But in other countries, people opt bicycle mode as a economic and as a environment friendly alternative, and people they choose bicycle transport mode more in other countries. Okay, but anyways, because of the many advantages, they must be given some importance. So the advantages of bicycle traffic are, we know that they use only human energy, and thus they can avoid the use of scarce oil based energy resources which are non-renewable. Okay, and they do not let out emissions, and they are noiseless. They require very small parking space. They are cheap, and in order to own and to operate, they are very cheap. Okay, so they are affordable. Okay, and they offer door-to-door mobility. So that is one important feature of this bicycle transport, that is they are door-to-door. They offer door-to-door mobility. Okay, so you can go anywhere, and that is a very important advantage of bicycle traffic. They can keep the rider in good health, because it's like an exercise also. They are safe when they are segregated from fast traffic, but they are safe only when they are segregated from the fast traffic, because otherwise chances of accidents are there, and the person who using this particular bicycle mode will be affected more by this such kind of accident. So they need to be segregated from the fast traffic. So my aim was just to give you an idea of what is this local area traffic management. So basically, local area means we are adopting certain non-motorized modes, and in order to promote this, and we are reducing the traffic flow. So pedestrianization means certain areas we are actually preventing, or we are banning, we are restricting the entry of motor vehicles to such areas. Okay, thereby we are giving the people, the users of that particular road, more freedom to travel, to walk, and to shop leisurely. Okay, that is the aim. Now we will be dealing with certain pedestrian flow models. So this particular how this pedestrianization is executed. Okay, so that is in order to study that, we need to know certain terms related to this particular pedestrianization. So basically we are going to study the capacity and performance analysis of. So performance analysis is based on the level of service. So how these non-motorized modes like pedestrianization and this bicycle transportation, all these, how it affects the performance, and how do we qualitatively and quantitatively estimate the performance. Before studying with that, we need to know that the transportation facilities and systems, they work under uninterrupted or under interrupted flow conditions. A freeway section without on and off ramps and a transit guideway between two stations are an example of uninterrupted. As you know, uninterrupted means it's a freeway section, whereas a signalized intersection and a rail transit station, they are all good examples of interrupted flow. So uninterrupted flow can often be approximated like the fluid dynamics, which we study in your S3. So how a fluid moves, how a water particle moves, so like that uninterrupted flow can be modeled. So such mathematical formulations can be applied in the case of an uninterrupted flow, whereas in interrupted flow, it is usually more complex. It involves more interacting elements and probabilities for event occurrence. So event means what? Accidents or collision. Okay, so there are also there can be there are signals in between the road section. So the chances of the flow getting stopped at a particular point is also very common in interrupted flow. So mathematical formulations usually yields capacity in units per hour. Normally we know that vehicles per hour, or so one or more, that is and one or more measures of effectiveness such as speed, density or delay. So here we will be discussing the conclusions of as obtained from highway capacity manual. So highway capacity manual or HCM include specific definitions for this level of service. So level of service will be marked as LOS hereafter. So LOS for each type of facility, LOS normally ranges from, that is level of service. So level of service is LOS. Okay, so LOS ranges from A, that is A means but the best. Okay, so if you are able to provide LOS A, then that means that particular section is the best. Then if it is the worst, then that means a road where you have to frequently stop, and the time taken will be very large, and you'll be saying you'll be very unhappy to use such a road. So such a section we will be giving the number F. F means the worst, and this is actually based what range we have to give. That is based on the range of values for a specific measures of effectiveness. So this is actually calculated based on the density for freeways and delay for intersections. So what is the density and what is the delay for the intersections, and based on all these we will be we'll be formulating certain mathematical models, and based on the equations we'll be arriving at a certain range of value for a certain section. Okay, so the range varies from A to F, and this is as per the HCM. HCM means highway capacity manual. So this all these values are based on the highway capacity manual. So we'll start with the capacity and performance analysis of pedestrian and bicycle facilities. So for that, here it is shown the pedestrian flow model. Okay, so this pedestrian flow model, so this is what is shown on this screen. Pedestrian flow model, it has been developed, and it has a close resemblance to the concepts of vehicular stream flow also. The speed of a particular pedestrian, that is a person who is traveling, he'll be having a speed, so that will be measured in the units of what? Distance divided by time. So we know normally in Indian conditions we normally refer to speed in terms of kilometer per hour or meter per second. Now next term is the flow. So flow is given in terms of the pedestrians per unit width of a walkway per unit time. So flow means what? It is the pedestrians per width of a walkway per unit time. So that is a number of persons divided by the width of the walkway. Okay, width divided by time. So in the denominator you will have width and time. Okay, and in the numerator it is the number of pedestrians. So that is the definition of the term flow. It is thus a point measurement in the same way as in the highway flow, where the point at which the flow is observed, it stretches across a number of lanes. So you can't actually measure like fluid problems. We have discussed about various flow measurement terms like steady state, unsteady, like that. Okay, so at a particular time, what is the flow? That is what we are estimating. So here also the term flow means what? At a particular time, what is the number? So suppose imagine that there is a street of width say 5 meter, and there are so many people are walking through that particular street. So at one particular instant, that is say at 10:15 a.m., what is the, okay, so that means you are just pausing that particular you are watching a video and you are just pausing, so you can at that particular point, at that time 10:15 a.m., you can pause the recordings, and you can count how many people are traveling through that particular street. Okay, a street where there are a number of people are traveling, so you can count exactly how many people are traveling or walking through that particular street at that particular time, that is say 10:15 a.m. So you know the number. And also, what is the width of that particular street? I told you it is 5 meters. So that also you know. Then what was the speed at which they were traveling? So if you know what is the instant of time, so that is the time. Okay, so if you divide the number of pedestrians by the width and time. So time means here it is we are for at that particular 1 second. Okay, so you will get the flow. So it is thus a point measurement in the same way, okay, as I told you before. So pedestrians they are normally not obliged to follow strictly any type of lane assignment. So they will be sometimes, if the whole lane is occupied by 1 or 2 people, then they will be walking straight. Okay, if more number of people are there, then they will be some people will be walking very slowly, and some people will be they want to reach they will be in an emergency, so they will be just crisscross. Anyway, they will be finding some shortcuts, and they will be traveling, and their speed will be different. So we can say that the pedestrians they do not it's not like an army people doing a march past or doing a parade, or it's not like that. People will be choosing their convenient path. So that is you can't strictly you can't expect them to strictly follow any type of lane assignment. But pedestrian flow per linear foot of walkway it is a tangible measure. Density is specified as the number of pedestrians per unit area. So we know that a number of persons, say 5 are there, and per unit area how many people are there. So that is how we calculate the density. The reciprocal of pedestrian density is called space. So if you take the reciprocal of this density, what is density? Density is the number of people per unit area. So number per, normally we know that density as mass per unit volume in the case of materials and all, but here we have to assume this is people who are, just imagine how take a road section and so many people are walking, okay, and they are walking for shopping purposes, not like in the case of march past or something. So people will be moving here and there, and they will be taking different stretches, they will be taking different lanes. So number of people by area will give you the density, and the reciprocal of this density, if you take the reciprocal of this value, then what will be this? So area divided by number of persons, so that will be the unit. So that is called as space. So its unit is surface area divided by pedestrian. So square feet, or if it is in feet, then it will be square feet per pedestrian. So its vehicular stream equivalent is spacing. Okay, so the fundamental relation Q equal to UK has been found to apply in the case of pedestrians under general uninterrupted conditions. So based on these terms, we will be evaluating the pedestrian flow model, and then we will be arriving at certain relations connecting these. So here basically what you have to learn is, there are 4 important terms. First one is flow. So flow means pedestrian per unit width per unit time. Then next term is what? Next term is the density. Density means what? Number of pedestrians per unit area, and the reciprocal of that is pedestrian. Reciprocal of the pedestrian density is called as space. So space means what? Meter square per pedestrian. Okay, that is it. Then there is a relationship, that is Q is equal to UK, and that can be applied for uninterrupted conditions. So these are the important prerequisites before studying this pedestrian flow models. Now here the first figure 4.2.1. So this presents the calibrated pedestrian speed density relationships obtained by 3 different researchers, and this diagram conforms to the general shape observed in the case of vehicular flow. That is, they are monotonically decreasing from free flow speed at 0 density to 0 speed at the jammed density. So as you can see here, the density, what is density? The number of pedestrians divided by square the area. Okay, that is persons per square foot, that is the unit. Then on the y-axis you can see the speed, that is feet per minute. Speed is given. So if you observe at the 0, that is the point where the x and y-axis meet, so you can see that the density is 0 and also speed is 0. Now what happens when the density is 0.1? So number of persons per square foot is 0.1. Then the speed is also, that is the speed is very high, that is nearly 280 to 320. That is the value at I'll tell you once again. Along the x-axis the density, and along the y-axis it is speed. So when the density is 0, the speed is what? 280 to 320. So for the straight line shows the commuters, okay, and the dotted line shows the shoppers, then dash line shows the students. So their speeds have been measured, and the researchers, they have plotted, and when the density is 0, the speed is very high. That means what? If in a particular street nobody is there, that is the density is very less, means number of persons are very less, so people are free to move at their own speed, their maximum speed. So you can walk at your maximum speed. Okay, since there is nobody, so you can walk at your highest speed. So some 280 to 320, that is the value. Now when the density is 0.1, again you what is the speed? The speed is about, it is coming to 200 or something. For the shoppers and for the shoppers and for the commuters, the speed is about somewhere near to 200, and for the students it is near to, what is the value, near to 280 something. Then when the density is 0.2, again you can see that the speed of the shoppers and commuters that has reduced to nearly 100 or something, and that of students also reduced, and that is again somewhat near to 220 or something. So you can see that when the density is 0.4, the speed is reduced to 0. So as the density is increasing, the speed is decreasing, and that has become 0 value. So what does it mean? Yes, since there are so many people are there at the road, people are jammed, they are not able to move, so everything has come to a standstill, and that is called as jammed density. So that particular lane is at its jammed density, means people are fully, that particular street is completely filled with people and nobody is able to move. So that especially earlier, especially during the Christmas seasons, during the Onam season and all, if you observe especially the day before Onam or one particular week before that festival, especially during Christmas also, you can see that the roads, and also during the times of the Attugal Pankala, you can see how the road near the that particular central area is occupied. So people are seriously jammed, and nobody is able to move. Or I am mentioning about the situations which prevailed before the corona. Okay, so those times we can say that people are jammed, and that is so very obvious that as the number of people or the density increases, the speed is getting 0, and they are reaching the jammed density. So that is simply mentioned in this particular curve. So you can, if asked about pedestrian flow models, you have to draw this. The values you don't need to exactly copy, but the shape of the graph you need to know. You need to know this. Along the y-axis it is speed, and along the x-axis it is density. So as the density is increasing and reaching 0.4, the speed has become 0. So this shape of the graph you need to clearly understand. So that is why I have explained it with such examples. Okay. So next we will be seeing the next curve, that is, you can see the curve, that is figure 4.2.2. So this figure presents the speed flow relationships corresponding to the above calibrated curve. That is, obviously here also you can see that the vehicular stream parallel extends to this diagram as well. The maximum pedestrian flow or capacity occurs at intermediate point between free flow and jammed conditions. So in this curve you can see that the flow is, here also along the x-axis the flow, and along the y-axis speed. So as the flow is increasing, you can see it reached a value of 35 for the outer curve, and the speed has increased, and speed again it is returning, and then no more flow is possible. So flow maximum is limited to 30. So you can see that the parallel it is also similar to the above. The speed once the flow has reached its maximum, you can see that after that this speed is actually getting reversed. So coming to the figure 4.2.3, the pedestrian flow and space, here also space, that is the square feet per person, that is the reciprocal of what? Reciprocal of density. So here also you can see that it is normally the space is increasing, reaching a maximum flow, and then thereafter it is decreasing. So that is the figure 4.2.3. It's a plot of the flow versus space. Then in the next figure, that is 4.2.4, you can see it's a plot of the relationship between speed and space. So these pedestrian level of service in terms of the space for walkways and sideways and queuing areas, the level of service can be shown as a table. So this is the level of service. So walkways and sideways, sidewalks, then based on the transportation terminals, queuing areas, level of service is given different values. I told you from A to F. A means it is the best and F is the worst. So next we will be moving on to the bicycle level of service. So here the concept of hindrance, that is taken as a measure for estimating the level of service on exclusive or shared bicycle facility. So whether it be exclusive bicycle facility or shared, the parameter used for measuring estimating the level of service is based on the hindrance. Okay, hindrance, it is the number of events as a surrogate measure. So number of events, again, that can be the main determinant of this number of events is based on a factor called MP. So this MP exclusive for exclusive and for shared type of bicycle facility, we have two different equations. So for MP exclusive, the equation is VO plus 0.118 into Vs, and for MP shared, the equation is 2.5 into VPO plus VBO plus 3 VPS plus 0.118 VBS. So here the MP, it is the total number of events, that is meeting and passing events per hour that the average bicyclist experience. So what is this event? Event means bikers passing in the same direction and meeting bikers who are traveling in the opposite direction. So that is event. So for a bicycle bicyclist, suppose if he is passing a particular or particular bike is passing that particular bicyclist, then that is one event. Similarly, if he is meeting a particular bike which is coming opposite to him, that is also another event. So that is this. So in that way, how many total number of events? So that can be calculated from these equations. So these equations again this V. So that is this MP, that is total meeting and passing maneuvers in 1 hour, that is per hour. Okay. Then what is this V0? It is the flow rate of bicycles on the opposing direction. Okay. And Vs is the flow rate of bicycles on the subject direction, that is same direction. VPO is the flow rate of pedestrians on the opposite direction. So VPO means what? That is the flow rate of people who are walking on the opposite direction, and VBO is the flow rate of bicycles on the opposing direction. VPS is the flow rate of pedestrians on the subject direction, and VBS is the flow rate of bicycles on the subject direction. So using this MP, that is total meeting and passing maneuvers in 1 hour, one then enters the table to determine the prevailing line of sight. So you have to just calculate, you have to obtain the values of these VO, VS, VPO, VBO, VPS and VBS, and then Substituting these in the equations, you can get the value of MP, and based on that the level of service of the bicycle flow can be obtained. So we will be dealing with the table also. Here this is the level of service for the pedestrian flow, which we have already discussed, and for the bicycle flow, this is the level of service for the bicycle flow. Okay, now we will see another figure which is showing the level of service on walkways, and this is taken from Transportation Research Board. As you can see here, level of service A. So we have already seen these A, B, C, D, E, F. I told you A is the best. So for pedestrian space, if the pedestrian space is greater than 130 square feet per pedestrian, then, and the flow rate that is less than or equal to 2 pedestrian per minute per feet, then we give it the level of service A. That means what? At walkway, the level of service A, the pedestrians basically move in desired paths without altering their movements in response to other pedestrians. Walking speeds are freely selected and conflicts between pedestrians are unlikely. So here you can see the flow rate is very less and also space is very large. So people are, that you can see that figure, that particular person, he is walking freely, only one person, so he is walking in a very in desired path, in whichever path he wishes, and he don't need to alter his movement in response to other pedestrians, because he has got enough space, and there is not much of people around, so he can choose his own lane, and he don't have to change his lane in response to other pedestrians. So he can also choose his walking speed. There is no conflict between any other. So that is very clear from that figure. Now level of service B. Level of service, we all normally, if you go to a park for walking, we don't like people coming and hitting, and we have to frequently change our paths, because one person is coming opposite, he is traveling at a very high speed, so you have to change to next right side, then again to left side. So such kind of walking nobody prefers. So that is a worst case, and if that is the situation, then we will give it the level of service F. So level of service B. Level of service B means if the pedestrian, so how we are giving this B is based on these two values, based on the pedestrian space and flow rate. So if the pedestrian space is greater than 40 square feet per pedestrian and the flow rate is less than or equal to 7 pedestrians per minute per feet, then at the line of sight, at the level of service B, sufficient area is provided to allow the pedestrians to freely select walking speeds, to bypass other pedestrians, and to avoid crossing conflicts with others. At this level, pedestrians begin to be aware of other pedestrians and to respond to their presence in selection of walking path. Whereas in the case of level of service C, the pedestrian space is greater than or equal to 24 square feet per pedestrian and the flow rate is less than or equal to 10 pedestrian per minute per feet. At this level of service C, sufficient space is available to select normal walking speeds and to bypass other pedestrians in primarily unidirectional streams where reverse directions or crossing movements exist. Minor conflicts will occur and speeds and volume will be somewhat lower. So here minor conflicts will occur if people are traveling in two ways, in two directions. Okay. Then level of service D. Level of service D means here the pedestrian space is reduced to greater than or equal to 15 only, and the flow rate is actually less than 15 pedestrians per minute per feet. At this level of service D, the freedom to select individual walking speed and to bypass other pedestrians is restricted. Where crossing or reverse flow movement exists, the probability of conflict is high, and its avoidance requires frequent changes in speed and position. The level of service provides a reasonably fluid flow, however, considerable friction and interaction between pedestrians is likely to occur. Level of service E. Here the pedestrian space is greater than or equal to 6 square feet per pedestrian, and the flow rate is less than or equal to 25 pedestrians per minute per feet. You can see the figure. Here virtually all pedestrians would have their normal walking speed restricted, requiring frequent adjustment of gait. At the lower range of this level of service, forward movement is possible only by shuffling. You have to shuffle. Insufficient space is provided for passing of slower pedestrians. Cross or reverse flow movements are possible only with extreme difficulties. Design volume approaches the limit of walkway capacity with resulting stoppages and interruptions to flow. Then level of service F. Pedestrian space is less than or equal to 6 square feet per pedestrian, and the flow rate is variable. At this particular level of service, that is F, all walking speeds are severely restricted and forward progress is made only by shuffling. There is frequent and unavoidable contact with other persons, other pedestrians. Cross and reverse flow movements are virtually impossible, and the flow is sporadic and unstable. Space is more characteristic of queued pedestrians than of moving pedestrian stream. So you can see the F, and you can compare A and F, how difficult it is. So especially in morning hours, if you go to the morning time and evening time, if you go to the park in Trivandrum, you can see this kind of different, this kind of all people are earlier, before corona, all people were walking, and for exercise some people will be running on their all for some people will be doing some exercises, and it will be so crowded and you'll have to frequently shift your path, and shuffling has to be done. So such kind of level of service, if that is what is prevailing, we will give it according to these numerical values. We'll assign it the value from A to F. So that is all about the local area traffic management, the pedestrian facilities and management, and how to quantitatively and measure this level of service. Okay, thank you.